Good morning, Miss Emily.
Morning.
Morning, Jacqueline.
Good morning.
Good morning, Erica.
Good morning.
Well, just have 3 people with me. Maybe somebody else will hop in a minute, but let's go ahead and talk. I want you to try this review quiz that I have on momentum. It's basically the first part of the test. Of course, you know, the test is not going to look just like this since it's going to be online, but it would be excellent practice for you for everything that we covered. Actually, I meant to show this to you Monday because it's everything we've covered from 4.3 to 5.5. And if you do that this weekend, it'll have you more than halfway ready for the test. We've got today and then one other day's worth of stuff before the test. And just because I haven't talked about it, I think I've said it in an email, but the test will be online. It will be in my math lab and very much like the practice test 3. So the momentum test, practice test, will be excellent practice for you. But as always, the My Math Lab practice test is the one that counts as a quiz. And in this one, the test will look more like that since it's online. Any questions about the test? Everybody good? Somebody say I'm good.
I'm good.
Good.
All right. Well, y'all were supposed to watch the 2.4 and 7.2 video before we Zoom today. So do you have any questions about anything that's on the front page of these notes?
No.
Yeah, I think I was okay.
You understand how to complete the square and when to complete the square? And how to, tell me this. How do you identify the equation of a circle? How do you look at it and go, this is probably going to be a circle?
Both of the x and y are squared, and then the coefficient is the same number.
Perfect. That's what you need to know. And not just the same number, but same positive number. If one of the x square or y square is negative, then it's not going to be a circle. If both variables are squared with the same positive coefficient, it's probably going to be a circle. Now, why am I saying probably? What could look like it's going to be a circle and then turn out not to be a circle? If what?
I know if the equation equals 0.
All right, so when it looks like a circle, but the radius is 0, what's a circle with radius 0?
A point.
Just a point. Yeah, just plot the center of the circle and that's all there is to it. What's the other thing that can happen that causes you to go, well, this looked like a circle, but it's not? This happened on either example 1 or example 2 on the back page.
The video didn't go over those.
Oh, let's go over them real quickly then. Did I get to number 34?
Yeah.
Okay, all right. Well, this is good practice for us. Let's complete the square on these two. Both of them look like they would be circles because both of them have x and y, both squared, both positive coefficients, and both having the same coefficient. So I'm thinking it's probably a circle, but I can't tell until I get it in center radius form. So let me be quiet for a second and you use your completing the square skills to get that in center radius form, and let's see why they're not circles. Were you okay on completing the square on those two? Anybody going, I don't know what you just did?
I was good.
Okay.
Yeah, I'm
All right. So when you complete the square on the left-hand side, of course, whatever you add to the left-hand side, you have to add the same thing to the right-hand side, and then you factor both of your trinomial squares. In example 1, what do you come up with on the right-hand side?
Zero.
Yeah. So it's still, you know, I'm just thinking, oh, this is a circle with center 3, -1, opposite of both guys in parentheses, and the radius is the square root of what's on the right-hand side, which means the radius is 0, and then all of a sudden I think, what does radius equal 0 mean? Well, radius equals 0 means you have that 1 point, 3, -1, but that's the only point in the whole wide world that makes this equation true. You can see if you let x be 3 and y be -1 in that equation, you would have 0 plus 0 equals 0, and that's a true statement. But there's nothing else you could let x and y be that would make this a true statement. So when you get radius is 0, that means you only have a point. And then in example 2, when you complete the square, what do you end up with on the right-hand side?
-10.
Negative, did you say 10 or 2?
10.
Okay, -10. And so I'm thinking, oh, it's a circle with center 3, -1, and radius the square root of what's on the right-hand side. And then I go, whoa, what's a circle with radius square root of -10? What is square root of -10?
imaginary.
That's an imaginary number. So what's a circle with an imaginary radius? I don't even know how to draw that. It's like a circle that has imploded on itself, or I like to call it an any belly button. You plot the center and then imagine it falling through a black hole or something bizarre. There is no ordered pair that makes this equation true, because something squared plus something squared can't give you a negative. So what do you write when, if the directions on the test said graph the following circles or graph the following equations, and you just graphed a point for this one, what would you write for this one?
No graph or
Yeah, if there's no ordered pair that makes it true, then there's just no graph. That's all you could write on that one. The thing that made number 34 just a little bit harder to complete the square was that you had to get both of these coefficients being 1 before you could complete the square. But that's, that's why I wrote out to the side the exact steps, because I know if we were in class, you would write down everything I had on each line, but you wouldn't have any words to tell you what I did if you go back and look at your notes 24 hours from now. So if you follow these steps, no matter what equation I give you, if the x and the y are both squared and they both have the same positive coefficient, but it's not 1, then this is exactly what you're going to have to do to get it in the form where you can complete the square. Did you run across anything, anywhere, any other circles that bothered you? Problems about circles? So we're all good on circles?
I think I'm okay.
All right. Then let's mention parabolas. We've graphed parabolas before. Actually, it was section 4.3 when I gave you an equation in vertex form that you could just look at it and see the vertex. What is the vertex on number 1 on this review quiz?
4 and 8.
4, 8 is the vertex. And then I gave you an equation in general form where you can't just look at it and see the vertex. How did you find the vertex if it's in standard form?
Was it negative b over 2a?
Absolutely. The little formula negative b over 2a. And on the test in class, most people would get this one right. Some people would get this one right, but some folks would just forget the formula negative b over 2a. Just completely forget that it exists. That's how you would find the vertex of a parabola that's given to you in standard form. But all of the problems in 4.3 were just vertical parabolas. They opened up and down. Their axis of symmetry was vertical. So what's different in 7.2 is we have some more of those vertical parabolas, but we also have some parabolas that open horizontally, either to the left or to the right. So how do we tell? Looking at number 39 and 40, how do we tell whether it's going to be vertical or horizontal?
Whether, go ahead.
If it's x squared, then it's vertical.
Right, because y equals x squared. This, I could get the y by itself and it would be y equals 1/4 x squared. That's what we graphed in 4.3. You can just look at that and see that the vertex is 0, 0, because there's no horizontal shift and there's no vertical shift. It's when the y that's squared, we haven't graphed those. So let me see if I wrote you this note. I don't see it, so let me add this note. Solve for the first degree variable. And number 39, we would get it in the form y equals x squared and know that it's a vertical parabola. But in number 40, we'd get x equals 1/8 y squared and know that it's a horizontal parabola. Now, when you're just looking at an equation, let's say I gave you 6 different problems and just said, what kind of conic section is this? How can you tell the difference by looking at the equation of a circle versus a parabola? What's different?
Only one of the variables is squared.
Right. All 3 of the other conic sections, the circles and the ellipses and the hyperbolas that we talk about in the next video, all of them have both, I'm sorry, yes, that was right. Circles, ellipses, hyperbolas, all of those have both variables squared. So it's a dead giveaway if you have an equation where only one variable is squared, that's going to be a parabola. And what determines whether it opens horizontally or vertically is which variable is squared. All right. Do you have any questions about any of those parabolas in the notes?
On the lesson we watched, you must not have had in your notes to put another point on the graph. You just told us to.
Oh, yes. Yes.
You just let one of them equal 0. I didn't know how to go on
Okay.
for sure.
Okay, I'm glad you asked that. That video is few years old. I don't know how old, but I had folks who could graph parabolas absolutely fine on paper, but they would struggle the way you have to graph it on MyMathLab. In MyMathLab, the first thing you have to do is either click on vertical parabola or horizontal parabola, so it knows which one to graph. Then you click the vertex, and then to make MyMathLab graph it, you have to pick one, or not pick, but find one other point. So you can either let X be something and find the Y, or you can let Y be something and find the X. Let's talk about these 2 just to make sure that you're okay with it, and you'll know how to find that other point on the graph in MyMathLab. Number 50, how do I know for sure that is not a circle? There's no way that could be a circle.
Because only one of the variables is squared.
That's absolutely right, because only one of the variables is squared. That automatically tells me it's a parabola. And I'm just talking about on the test if all these were mixed together. I didn't have 6 parabolas in a row. They're all mixed together. How am I going to know which ones are parabolas? The one that only have one variable squared. Once I identify that it's a parabola, I'm going to solve for the first degree variable. I'm going to try to get this Y by itself. Now, I need it in vertex form so that I can see the vertex. So I'm going to get my X's on one side and my everything else on the other side. I'm going to add 4Y and subtract 1 from both sides, and then complete the square so that I can factor that left-hand side. What would I add to the left-hand side to complete the square?
9.
You say half of 6 is 3. 3 squared is 9. If I add 9 to the left, I have to add 9 to the right. And that left-hand side factors into X plus 3 squared. That's why I wanted to complete the square so I could factor it. The right-hand side cleans up to be 4Y plus 8. And now we're ready to get that Y by itself. First thing I do is subtract 8 from both sides. And then divide both sides by 4. When you divide by 4, make sure you divide both of these terms by 4. Well, actually all 3 terms by 4. And this first term looks kind of weird the way that it's written. What's the coefficient? If I didn't want to put that all over 4, how could I write the coefficient of X plus 3 squared?
It's 1/4.
Yeah, I'm proud you got that because I don't think I asked it very well. That's 1/4 x plus 3 squared minus 2. If it bugs you at all that your y ended up on the right, then you can pick up the whole thing and flip it over, but you don't have to if that's not bugging you. All right, now that I can see which variable is squared, actually I could have seen it up here, but it's even easier for me to see here whether this is a horizontal parabola or a vertical parabola, because it's in the form y equals x squared. Is it horizontal or vertical?
It's vertical.
Yep, that's the kind of parabolas. That one looks just like that one. You can just look at it and see the vertex. So it's a vertical parabola. And because we got it in this form, I can also look at it and tell you the vertex is what?
-3 and -2.
-3, -2. All right, so in my math lab, as soon as I realize it's vertical, I'm going to click that button so it'll know how to graph. And then I'm going to plot -3, -2, but my math lab doesn't know how wide the parabola is or whether it opens up or down or what until I give it another point. So I just completely lost my train of thought there. You have to squint just a little bit hard here, but can you think of some value of x? Now, I could let x be 10 if I wanted to. 10 plus 3 is 13. 13 squared is 169. 169 over 4, I don't want to graph that. I don't even want to let x be 0, or I'll have to graph a fraction. 0 plus 3 is 3. 3 squared is 9. 9 times a fourth is 9/4. I could deal with that. But can you think of some value of x that would not give me a fraction here, just to make it easier to graph? You can squint hard and tell me, what could I let x be that I could take a fourth of this whole thing? Tell me what kind of numbers I can take a fourth of and get a whole number. The word I'm looking for starts with an M.
I'm blank.
That's okay. I was trying to beam it to you. I was trying to beam it. Multiples of 4. I can take a fourth of multiples of 4 and get a whole number, right?
Right.
So what could I let x be that would make this a multiple of 4? Somebody say 1.
1.
Yes, yes. 1 plus 3 is 4. 4 squared is 16. I can take a fourth of 16. So that's probably what I would choose for my other x value. My other point, I'm going to let x be 1 and then see what I would get for y. So like I was saying, 1 plus 3 is 4. 4 squared is 16. What's a fourth of 16?
4.
And then 4 minus 2 is 2. So I could click that other point and my math lab would finish the graph for me. If we were doing the test on paper, you wouldn't have to find that other point. You could just, because I don't really care about how wide your parabola is. As long as you had the vertex and a parabola that opened up, I would count it right on a paper test. But to get this right in my math lab, you do have to have some other point. And sometimes it takes a little squinting like we did here. I think we should do one more, but it takes a little bit of squinting to figure out, well, what can I let x be that I don't have to graph a fraction? And if you do have to graph a fraction, there's a little symbol in my math lab that looks like a magnifying glass. If you click that magnifying glass, it makes the graph bigger, and up in the right-hand corner, it has ordered pairs for wherever your mouse is. So if you do need to graph 5.5, make the graph bigger, and then keep an eye on these disordered pair as you move the mouse, and just don't click it until you see X is 5.5. But I'd still rather pick an X that I don't have to graph a fraction. You want to see one more of those, or are you good?
Well, the video didn't go over 52.
Okay, let's do it then. Why don't you look at what we just did in 50 and see if you can copy the same steps in 52. I'll give you just a minute to work on it. See if you can get the X by itself, since it's the first degree variable, like we did the Y here. Is that what you ended up with when you completed the square?
Yeah.
Okay, now I'm glad we did this one, because there's another caution I need to give you. I could have told in the very beginning, because only one variable was squared, I could have told that that was going to be a parabola. And because it's the y that's squared, what does that tell me about my parabola?
It's horizontal.
It's horizontal rather than vertical. And because the coefficient is positive, when you have a horizontal parabola and the coefficient is positive, how does that tell you the parabola opens?
Right.
Correct. Just like positive coefficient here told me the parabola opened up. So it's a horizontal parabola which opens right. But when I say, what's the vertex? It's really easy to glance at this and say, well, there's no vertical shift, so it's 1, 0. But that's why I made you, let me see what you need to highlight right here. This is going to be important with ellipses and hyperbolas too. Well, let me take that back. Whatever is with the x is the x coordinate. Whatever is the other variable is your y coordinate. Here, my vertex is HK. H is the x coordinate of the vertex. Oop, H. HK is the vertex, and the H is the x coordinate because it's with the x. Here, the vertex is also HK. K has to be the y coordinate of the vertex because it's with the y. And as tempting as it is on number 52 to just look at it and say the vertex is 1, 0, that 1 is with the y. It's the y coordinate of the vertex. The vertex is 0, 1, not 1, 0. Does that, excuse me, does that make sense?
Yeah.
Okay, watch out with that. Even with an ellipse, when we talk about them on the next video, if I reverse those two ordered pairs, I had the y minus k before the x minus h, the vertex would still be hk because the h is with the x and the k is with the y. So just watch out for that. All right, so we have found what the parabola looks like. We have found the vertex. I need one other point, only to make my math lab happy. Can you squint hard enough? And there's many answers here, infinitely many answers, but can you squint hard enough to tell me something I could let y be so that I would get a number that I could take an 8 of it? What kind of numbers can I take 1/8 of?
The multiples of 8. I guess.
Yes, I was getting you to say multiples of 8. I just need this to be a multiple of 8. Well, what could I let x be that if I subtracted 1, I'd get a multiple of 8? What could I let y be to make the value inside of the parentheses equal 8? I'm fixing to climb through the computer and bop you on the head.
That would be interesting.
What can you subtract 1 from and get 8?
9.
Yes. Yeah. Just let y be 9. And then figure out what x would be. If you let y be 9, you'd say 9 minus 1 is 8. 8 squared is 64. What's 1/8 of 64?
That would be 8.
Yes. So you could use that for your other point. You don't have to, but it would work. If you squinted a little bit harder, you may find a smaller number you could let y be. If you let y just be 5, what's 5 minus 1?
4.
And 4 squared is,
16.
and 1/8 of 16 is,
2.
so that would work also. So it can take just a little bit of squinting, but if you have a fractional coefficient, you're just trying to make the number inside the parentheses be a multiple of that denominator. Does that feel a little better, Jacqueline? That's not
Yeah.
Jacqueline. Yeah, that is Jacqueline?
I don't know, but it does feel better.
Okay, okay. Anything else you want to ask from the video? Or any other problems in the notes that we didn't do on the video?
I think I'm okay.
All right, anybody else? All right, y'all be getting ready for that test. And like I said, the best thing to do right now to get ready for that test is that quiz that I had in Momentum, and then I think I mailed it to you. I want to look at the calendar real quickly. Let's see. Yeah, the test is next Wednesday. So we have people that haven't been able to join us or haven't joined us in the Zoom, I'll send them an email that says test next Wednesday online, but it will be at our regular class time. So it's going to be open from 10 to 11:30, and you need to take it during that time. Okie dokie.
Okay.
All right. Y'all have a good day.
Thank you. You too.
Bye-bye.
Bye.
Bye.